So today, main topic of our discussion is going to be 12.6. That is resistance of system of resistors. We have already started this in the last session, but what we have gone through was series circuit. Today we'll be talking about is parallel circuit. Okay? Series we have already seen. Today we'll be talking about parallel circuit. So this is part 2 of 12.6. So 12.6 again we are going to discuss, but this is part 2 regarding parallel combination. Now, first we will just revise what is parallel combination. So parallel combination looks something like this. We already know what is parallel combination. It is nothing but a connection of resistances between two common points. So okay, so we can see that there are three resistors here and they are all connected between two common points A and B. So if there are two common points in which they are connected, these are called as parallel combination. This definition we already seen last time, so we are not going to talk much about this. Today, we'll be talking about its derivation, its formula. Now, always remember, in every exam, board exam, you will always face this kind of question, derivation question. So, either they will ask on series or either they will ask on parallel. So, be ready with all the derivation. Okay? And this is a very important question. It is asked almost every year in the exam. At least derive equation for series or derive equation for parallel. This they always do. Now, as we have activity for series circuit, so in the same way for parallel circuits also there is one activity in the textbook named as activity 12.6. So that activity 12.6 is regarding this only, what parallel circuits. So let me explain you what is given in that activity. So this is the diagram they have given there. This is our normal diagram which we have seen even in last session. The cell combination along with R1, R2 and R3, you can see there is X point and Y point. So this is basically a parallel circuit because they are connected between two common points, X and Y. A voltmeter has been added for measuring potential difference of X and Y. So you can see potential difference has been added to measure potentials at X and Y. And a common ammeter is also given. Switch is always common, so that is also given. Now, let us just try to understand what happens during parallel circuits. So I have given you focus on this arrow, this yellow colored arrow. The current has started from positive terminal. The current has started flowing. So current has started flowing. Now it has gone up. Okay? It has started from positive terminal, has gone towards upper side. Now it is going to reach that X point. Okay? X point. But problem with X point is that there are three routes. यहाँ पे तीन रास्ते हैं. There are three roads through which it can pass. This current can go through L, it can go through P, it can go through S. But electricity is very smart. What electricity does is it divides itself. It divides itself in such a way that it will pass through L also, P also, and S also. So this is what is going to happen. So this current I, you can see this current I, this letter I is getting divided into three currents, I1, I2, I3. Why? Because you have connected these circuits in parallel. So current has to divide itself. वो ऐसा नहीं होने वाला है कि it is going to just take one path, that is through R1 or just going to go through R2. It is going to divide itself between I1, I2 and I3. So let us see what happens next. They are going to continue their journey. Again, they have continued their journey. Afterward, they are again going to reach which point? Y point. So they have reached Y point. And after this, see, all we have seen is at point X, they got divided. Okay? They crossed L, P and S. Then they reached M, Q and T. And then they reached Y. But at Y, they will combine themselves. And again, we will get I current. Okay? Matlab, initially that I was divided into I1, I2 and I3. But again, the same current is flowing. That means they combined themselves. And that current you can see in this here, suppose they have already mentioned in the diagram, I is again returning. So that means it went with I, got divided into I1, I2, I3, again combined itself at Y into I, and then the journey continued. So this is the journey they are taking. Again, it will go through ammeter and then through the switch and then to the battery. Very simple. So it's a very simple connection which is given. So at least do you agree that this current was divided here? So give me response in chat box. Do you agree that this current was divided in this process as you know the connection was parallel? Fine. So at least can we say that compared to series circuit, Current in this case is not same. Current is not same. In series circuit current was same, but in parallel circuits, in this circuit you can see the current which was available, this current is not equal to I1, I2 and I3 because these values are lesser. I1, I2 and I3 were created from I, so they are not equal to I. In this particular parallel circuits, I1, I2 and I3, they are not same as I. Understood this point, that current I1, I2 and I3 are completely different as compared to I. Right. But you have to also see that X point and Y point were same. All these resistors, all these three resistors were connected between the same point, X and Y. So that means their potential difference is same. Their potential difference is same. Why? Because their points are common. That is actually the central idea of this particular parallel circuits. What is the central idea? That current is different in parallel circuits, but potential difference is same. So this is the actually idea. Electric current is different for parallel combination and potential difference is same. This is reverse case of series circuit. In series circuit, current is same, potential difference is different. But in parallel circuit, current is different and potential difference is same. I hope this point is clear. So give me response in chat box. Have you understood that electric current is same in is different in parallel combination and potential difference is same. We have seen the current got divided, hence the current is not same, and they were connected between two parallel points. So hence potential difference is same. Okay. Now what we'll do is we will be deriving this equation. Okay, we will be deriving this equation. Okay, Ritesh, what you are saying, Papadwar? If you have certain doubt, you can type it in the chat box. Just writing down doubt, I won't understand what you are saying. Instead of writing down their doubt, just DOUGST, and that too it's a wrong spelling. Actually give your actual doubt there. Write it down. Okay? How would I understand it? Okay, till that moment, we will be going with the derivation. So let us have our circuit. So this is our circuit, right? That is given in that activity. For us, potential difference is same. We already have seen that this potential difference is equal to V1, V2 and V3. So this is what is same in parallel circuits. Now, according to Ohm's law, V is equal to IR. Okay? But before that, this current which we started, this current, okay, it got divided into I1, I2 and I3. And later on we saw it got combined at point 1. So initially I was divided into I1, I2 and I3. Then it combined at Y. So we can say that I is equal to I1, I2 and I3. These all where I1, I2 and I3 were created from I. So we can say if we add them, we will get the actual current. So I is equal to I1, I2 and I3 addition. But from Ohm's law, we already know V is equal to I into R. That is the formula. So for formula for I would be V by R. Formula for I would be V by R. Okay, that would be the Ohm's law. Now we have found the value of I from this equation. In the same way, we have to find the value of I1, I2 and I3. Okay, all the values we have to find. So what would be the value of I1? I1 would be equals to V1 by R1. I2 is equal to V2 by R2. I3 is equal to V3 by R3. In this way, I1 would be equals to V1 by R1. I2 is equal to V2 by R2. I3 is equal to V3 by R3. Okay, we have just modified them for these numbers. Now what we'll do, we will put all these values into this equation. Okay, value of I we already have, I1, I2 and I3 values we also had derived. So let us put all these values into this equation. So that equation will become, see, value of I is what? V by R. So we have put V by R. What about the value of I1? So that is V1 by R1. Same V2 by R2, V3 by R3. But initially only we have seen in parallel circuits, potential difference is same. That is V is equal to V1 is equal to V2 is equal to V3. So let us just put in place of V1, V2 and V3, I will place only one value, that is V. We will replace V1, V2 and V3 and place V. So we are going to cancel out this V1, V2 and V3 and we will put a V value there because all these values are equal to capital V. Okay, so I can replace V1, V2, V3 with V, V and V. But you can see on the right hand side, all these things V, V and V, we can take common. Okay, outside the bracket we can take it common. So let us take it common. So I have taken all the V's outside, and inside what is remaining? 1 by R1 plus 1 by R2 plus 1 by R3. Now it is very easy. Concentrate on left hand side and right hand side. We can cancel this V. So what is going to remain? 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So this is what is remaining. Why? Because V and V got cancelled. So what is remaining is 1 by R is equal to R1 1 by R2 plus 1 by R3. And as this is what is this one, this particular R, this is the total resistance of this circuit. And as our circuit is parallel, so what we'll do, we will give it a letter. We will say 1 by Rp. What we will call it? Rp. Why? Because this is the total resistance of parallel circuit. So let me just replace that R with Rp. Why? Resistance of parallel circuit is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So this is actually the derivation. So you do one thing, take a screenshot of this. Later on, you can, write it down in your notebook. Meanwhile, whoever students have written their doubts, I will, answer those. Okay, Ritesh, what is your doubt, sir? There is voltmeter. I am not understanding your statement. What is the statement? Sir, there is voltmeter is there. What is the meaning of the statement? Yeah, do one thing. If you are not able to ask your doubt in English, write down in Hindi. Okay, I can understand that. No issue. Okay. Till that time, we will move to the next one now. We are going to solve example 12.8. So in example 12.8, we see what kind of question is there, and we will use the formula of parallel circuits to solve it. So this is the question they have given. They have said in figure 12.10, suppose the resistances have a value of 5, 10 and 30. So they have said value of R1, R2 and R3 they have given in the question. Then they are saying they have connected it to a battery of 12 volt. So this is a battery, and what is the voltage? 12 volt. Then they are saying calculate current through each resistor. So they are asking us to calculate current through R1, through R2 and through R3. And what would be those currents? I1, I2 and I3 they are asking. Then they are asking total current, means this I value. And then they are asking total resistance. So total circuit resistance is very simple. That is just a parallel circuit. So first we will calculate current through each resistor. Now to calculate current through each resistor, the values we need is this one. So what I have done is I have written those values 5 ohm, 10 ohm and 30 ohm here. 12 volt was already given by them. You can see 12 volt was given. So I have written it as well. Now I am supposed to find in the first question, they are asking us to calculate current. So let me write it I1, I2 and I3. Okay. Formulas for these are based on what? Ohm's law. So I1 is equal to V by R1, I2 is equal to V by R2 and same. Why I have not used V1, V2 and V3? Because V1, V2 and V3 are equal to V. This is parallel circuit, no? So V1, V2 and V3 are equal to V. So I can put the values there. So these are the values. V value is 12. So I will keep 12, 12, 12. And R1, R2, R3, 5, 10 and 30. We can divide them now. 5 ones are, 5 twos are, 2 basta hai, 0.20, 4s are. And this one 1.2 in the same way. So that would be 2.4, then 1.2 and zero point 0.4 ampere. So that is the current value for I1, I2 and I3. So we have got the answer for 1. Second question they are asking is total current. Total current. How we can find out total current? Just add all these, no? To find out value of I, we know that it can be taken from addition of I1, I2 and I3. So let me put I is equal to I1, I2 and I3. You just have calculated I1, I2 and I3. Just add those values there. So it would be what? 2.4 plus 1.2 plus 0.4. Same values which we just got. Adding all of them will give us the answer what? 4 ampere. Very simple. So all we had to do was calculate individual current and then add them. So we have solved first and second. Now concentrate on the third one and do not write this. This is anyway a solved question in our textbook, so no need to write. Now in the third question they are saying total circuit resistance. Okay, total circuit resistance. This is a parallel circuit. So we have to use the formula 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So let us put the values. R1 value we already have 5 ohm, 10 ohm, 30 ohm, 5, 10, 30. So we have added those. Now we can take LCM of this. What we'll do? We'll take LCM as 30. So let me take LCM as 30. So LCM I have taken as 30 and 5 how much the 30? 6 plus 10 how much the 30? 3 3 and plus 1. So this is the LCM part. Now 6 plus 3, 9, 9 plus 1, 10. So 10 by 30. So what actually I am getting is 10 by 30. And 0, 0 I can cancel. So it will become 1 by Rp is equal to 1 by 3. Okay, 0, 0 I have cancelled. So answer, final answer is 1 by 3. But you can see Rp value is given in denominator here. So what I have to do is I have to take it to numerator. Okay, inverse I have to take it. So if I take this to the numerator side, this 3 will also go to the numerator side. So Rp, 1 by Rp is equal to 1 by 3. I have to calculate value of Rp. So what I will do, I will take it to the numerator side. So Rp would be equal to 3 ohm. How? Because 3 would also be going to the numerator side. So total circuit resistance is 3 ohm. So give me response in chat box. Have you understood this? It's just you have to take those particular values and add it to the formula. That's it. Okay, Ritesh, what you're asking, will electricity pass through voltmeter? Definitely electricity will pass through voltmeter, but we have not taken into account because we have already seen in the last session that voltmeter has high resistance. So there is no point in taking the current value of voltmeter, as voltmeter has high resistance. So very little current is going to pass through it. So why to even take it into account? It is negligible. Okay. Sanskriti, what you're asking, sir, while studying difference between ammeter and voltmeter, there was a point that ammeter is always connected in series and in figure parallel ammeter is there. In which figure are you talking? Ki ammeter is always connected in series. You can see here, it is connected in series. The current is going through this way and it is connected in series. एक के बाद ही तो है. It is not connected in parallel. This is called as parallel connection, voltmeter, as it is connected between X and Y. This is parallel, ठीक है, voltmeter. But you can see after this Y, this current is going through A, so that means ammeter is connected in series here. Okay, now let us go to the next question. It is example 12.9. In this case, what they have done is there are two combinations which are given. So let us try to understand this first and then we will solve the question. So you can see there is a battery arrangement here. Current is going through R1 and R2, but you can see they are in parallel. ठीक है, एक के ऊपर एक. They are connected between two common points. So R1 and R2 are parallel to each other. Then the current is leaving and going through ammeter. ठीक है, ammeter is connected in series with this. ठीक है, इसके बाद है, कोई common points के बीच में नहीं है. So ammeter is in series. After ammeter, the current is going through R3, R4 and R5. But you can see the current is again getting divided here. So that means R3, R4 and R5, they are parallel to each other. So R1 and R2 are parallel to each other and R3, R4, R5 are also parallel to each other. So what I will do, they are asking for total resistance. First, I have to find the combination of R1 and R2. Then I have to find combination of R3, R4 and R5. Then I have to combine them. Okay? So first we will calculate for R1 and R2. Let me put all the values. These are the values given in question. 10 ohm, 40 ohm. So I have put those values. Okay? Everywhere. First, we have to calculate total resistance. So what we'll do, we will just assume total resistance as RA. Okay? In the same way that in algebra you always take a variable, right? Let X be the value. So what I am proposing, what I am suppose, let's say adding here as a variable, I am adding RA as a variable here. So 1 by RA is equal to R1 plus R2. So I am calculating combination of R1 and R2 only. Okay? For the first instance, I am not talking about R3, R4, R5. Just focus on R1 and R2. First we will calculate this, then we will go for R3, R4, R5. So what is the value of R1 and R2? 10 and 40. 10 and 40. We'll take LCM of this. This would be equals to what? 40, and on top of it, it will come as 4 plus 1. Okay, 4 plus 1, 40 at the denominator, and 4 plus 1. This is LCM what we have taken. Now 4 plus 1 is 5, 5 by 40. So this answer is 5 by 40. Again, we can use 5 ones are 5, 5 eights are 40. So value would be 1 by 8. But you can see the value of it is, we want to find the value of RA, and that RA is given in denominator. So what I have to do is I have to take reciprocal of it. So RA would be equals to 8 ohm. This 8 will go to the numerator side. Now I will find values for R3, R4, R5. So for R3, R4, R5, I am assuming RB as the total resistance. Okay, RB as the total resistance. So R3, R4, R5 values are already known, 30, 20, and 60. So let us put it there, 30, 20, 60. So 30, 20, and 60. Second thing we already know, we have to take LCM of this. So what value will take for LCM? 60 will take. Okay, so 60 value we have taken, and then you can just add it. 2 plus 3 plus 1. That addition would be what? 3 plus 2, 5, 5 plus 1, 6. 6 by 60. And 6 ones are 6 tens are. So that would be 1 by 10. So value of RB would be what? 10. Okay? 1 by RB is equal to 1 by 6 ones are 6, 6 tens are. And then I have to take reciprocal. So RB value would be equals to 10 ohm. Okay. But you have to understand that we have to talk about total resistance. Okay? Total resistance. Total resistance. But you can see here that total resistance here, they are in series connection. This particular circuit R1 and R2 are connected to this circuit R3, R4, and R5, and they don't have common points. So hence R1 and R2 combination, that is RA, is in series with R3, R4, and R5. So we have to add them directly. So that addition would be 8 plus 10. So that would give us 18 ohm. Okay. Why we have added RA and RB? Because you can see they are connected between two common points, R1 and R2. Hence they are parallel. But the combination of this is directly connected to this second combination. So this is a series combination. Okay. We will be talking more about these in whenever suppose our school reopens. But for now, at least understand that this is a parallel combination and this is the second parallel combination, and they are not connected between the same 2 points. Hence, it means that they are in series. Okay? So that means the total resistance would be 18 ohm. Okay. Second thing they're asking us is total current. So that we can also find, we can have to use Ohm's law. So V is equal to I into R total. So this R total we already have. How much is the value? 18 ohm. So that value we know. This value we have to calculate I. V is already given. What is the potential difference? 12 volt. So let us put those values. 12 is equal to I into 18 ohm. Now this 18 we have to shift. So I would be equals to 12 by 18. We can divide it by 2. 2 6 are 2 9s are. So it would be 6 by 9. Now we have to directly divide 0. Okay, 60. 9 6 are 54. Then again 6 are coming. So that means 666 the value would be. So that would be 2 by 3. And that would be the total value would be 0.6666. Okay, ampere. So this is the total current. You can even round it off to 0.67. Okay, it's up to you. If you can keep this value as 0.66666, or you can round it off to 0.67. Both answers are correct. Okay, it's totally up to your decision. Now we have to talk about just last one more point, and then we will go for your doubts. Okay, so focus on this particular diagram. One question they will be asking you is, out of series and parallel circuits, which won't stop working if one device fails? Means what they want to say is, अगर कोई device खराब हो जाता है from the circuit, if it stops working, will the circuit stop or not? That is the question. ठीक है? So in parallel circuits, what happens is, suppose let us say we will assume that R1 is stopping. ठीक है? R1 has got damaged. ठीक है? It is not working anymore and current is not flowing through it. They are asking us, will the current flow through R2 and R3 and will it reach battery? So definitely it will reach, because you can see the current is flowing through this point, reached X, even if the path is not clear, suppose this path is not available, the R1 path, still the current will flow through R2 and R3 because these paths are open, these devices are working, no? And this combination is what? Parallel circuit. That means in parallel circuits, even if one device doesn't work, even if one device doesn't work in parallel circuits, still all the circuit will still be in on condition. All the circuit will still work even if one of the device stops. Doesn't matter because parallel paths are available in parallel circuits. Okay, so that is the one question they'll be asking in the exam, that out of series and parallel, which circuit will still work even if one of the device fails. So answer is what? Parallel circuit. So parallel circuit is the combination in which even if a device stops, those circuit will still work. Now